Okay, in this example we are asked to reflect the figure, which is a triangle, over the line y equals -1. Now the line y equals -1 has been drawn for us. It's here in the blue, but just to jog your memory, if it's an x equals number line, that is vertical. If it is a y equals a number line, that's horizontal. So in this case, our line of reflection is y equals -1. We need to draw a line through -1 on the y-axis, and our line needs to be horizontal. Okay, the next thing we want to do is just make sure we can see all the vertices of the triangle that was given. There they are. And we just want to find out how far they are from the line of reflection. So I will draw, I'm going to keep using that highlighter. This point is 2 units away from the line of reflection. That means that you need to go 2 units below the line of reflection and put another point. And that point is going to be our first reflected point. I'm going to draw it right now. There we go. Okay, now I'm going to change my highlight color and we'll go to purple. Let's do the next one. How far is that point from the line of reflection? You can count the boxes, or you can see that we're going from 7 on the y-axis to 1. That's a total of 8 units. So if the first point is 8 units above the line of reflection, my reflected point should be 8 units below the line of reflection, which is going to be right there at the end of that purple line. So now I'm going to draw another dot. Okay. And the final piece is now to do this last point. That last vertex is 4 units above the line of reflection, so we need to go 4 below. Okay. Now let's put a dot there. And the picture's drawn. Couple things to point out about this. I should see the same size shape. It should be a congruent shape because reflections are a type of rigid transformation. Rigid transformation means that even though you're doing something to the image, it's not actually changing the size or the shape. So the angles are the same. The lengths of the sides are the same. The only thing that's different is probably the location and also the orientation. You know, if I were going to say this was point A, this was B, and this was C in the original, then A is actually now pointing down here at the bottom, B is over here, and C is over here. A prime, B prime, C prime. So the difference is the position and the orientation. Let's go ahead and hit submit and see if we're correct. All right, we got a check mark, so it's looking pretty good. I want you to see the animation though as well. And that's a reflection over the line y equals 1. All right, that's what you need to know about reflections. You would do the same thing if it was a reflect over a vertical line. You would just go the other way. So let's see if I can find one of those for you. Yep. And for this one, I'm just going to show you the solution. But take a look at how the directions have changed here. In this problem, it says to reflect the figure over x equals -2. That is a vertical line going through -2. So I see a vertical line has been drawn for me. Otherwise, I would draw it myself. And when we reflect, we're going to find out how far these are from the line of reflection and then reflect each point so it's equidistant to the line of reflection. So that point looks like it's 1, 2, 3 away, so I'm going to draw another point 3 away. Now I'm not going to complete this one because it's the same process as before, but I will show you the animation. All right, here's the solution. See all the lines that are drawn? Those lines are to help us figure out where the new points go. Those two figures are congruent, their side lengths are the same size, their angles are the same. That's a rigid transformation, meaning that the one shape mapped onto a congruent shape. And that's it for reflections.